Alright, this will be a video reviewing the Chapter 1 PowerPoint. There will not be a video for every single PowerPoint. I just think that there are some things in the Chapter 1 video that need a verbal explanation of what it means. You'll see that there is a lot of slides, and I will not be going through every single slide. I'm going to kind of jump around to the ones that are important, or the most important. What is statistics? Stats is basically the collection of data. So we have polls, studies, surveys, other ways to get data, and then we organize it, we calculate some values, and we analyze it. A stat is just basically a number, but it does not necessarily need to always be numbers about other numbers. So it doesn't need to be an average of, say, test scores. It could just be a collection of data about what favorite ice cream values or favorite ice cream flavors are. It does not need to always be numbers about numbers. It could be a number about a descriptor. So because of that, the data that we collect doesn't necessarily need to be like a measurement or a test score. It could be a gender. It could be yes, no. It could be what type of dog do you have. It could be something that is a description and not just a number. The population is the everything. So anybody who fits that description and that can be put into that category is the population. So if we talk about all the students at Mitchell Community College, every single person that is enrolled in a class at Mitchell Community College would make up the population. If I wanted to talk about a value for every single person, that would be a census. So if I collect data from every single member of the population, then when I crunch that data would be a census. But normally we don't get from everybody. Sometimes it's just too many people. Sometimes it just takes too much time. Almost always we're talking about a sample, which is a sub-collection. And so instead of me talking to every single person that goes to Mitchell Community College, I may pick certain classes to go to, and I'll just talk to a sub-collection of that population. It is important that your sample that you choose to talk to is collected appropriately, because if it's not collected the right way, the data will most likely be completely useless, because I'm going to then only have certain parts of the population may be represented, and I may make some bad decisions, and I may have done that on purpose, I may not have. So it is very important to make decisions based on a good sample that represents everybody in your population. So you got to think about the context of the data, the source of the data, and the sampling method, amongst a couple of other things that are important. Uh, the source of the data are they objective? Are they being biased? Is there incentive to distort what they are saying? Do they have something to gain or lose? So anything that somebody maybe has an incentive, their opinion may be a little, it may be their opinion and not something that is an objective source. They may have a reason to say what they have they are saying, and it may not be because that's what the data said. A sampling method that is always a terrible way to collect data, which is probably the most popular way to collect data, is a voluntary response. So somebody annoyingly calls your cell phone and starts asking you questions. They want to knock on your door. They send you a poll in an email. Those voluntary responses where you can say yes or no, like yes, I want to participate, or no, I don't, are never very good. Those are voluntary responses. A lot of people use these responses to make decisions. Like Amazon, you write reviews. Those are all voluntary. Only two types of people will give responses to voluntary response samples: people who are super happy and people who are super mad. So you go into those Amazons and the reviews, and there's like a boatload of fives and a bunch of ones, but there's not a whole lot in between, because only people who are very happy or very upset are going to take the time to say what they have to say. Everybody else in between is like, it was all right. It didn't cause me one emotion, one strong emotion or another, so I'm just going to let it be. So you never want to take into consideration really these voluntary responses. Um, let's keep going. What are some different types of data? A parameter is the data associated with the entire population. So There are 100 senators in our Senate. We say 55 are Republican. So that is a parameter because I'm talking about all the senators that we have. I didn't take a subsample of senators. It's just those are all the senators. So anytime I talk about a number associated with the entire population, that's a parameter. Most of the time we're talking about statistics, which is something that only has to do back to the sample, which is this is an intro to stats class and not an intro to parameters class, because we're almost always dealing with samples. So in 1936, Literary Digest polled 2.3 million people in the United States on a voluntary sample, right? 57% they would vote for Alf Landon, which you have never heard of, most likely, because he lost. It was a bad sample. So we got a statistic. It was collected. They didn't make up their own stuff, but they took a bad sample. And so we got a statistic that did not help us make an accurate prediction about the entire population, right? Or else Alf Landon would have been president. We can talk about quantitative, which is numerical, which we prefer to talk about. And when we talk about numbers, we can talk about discrete or continuous. Now, here is the thing with discrete and continuous. A discrete number means a whole number. It means you have to have 1, 2, 3, 4 of those items. You cannot have half of an item. So, like, you can't have 1.5 kids. You can't have 3.75 cats. You can't have 4.5 eggs in a crate. Things that you can't have a part of, a piece of, those are discrete. Continuous, those are the ones that you can have a portion of. So I can have 2.5 gallons of milk. I can put 3.5 gallons of gas into my car. Things that you can have a fraction of are continuous numbers. Things that you have to have the whole thing, 1, 2, 3, 4, 5, those are discrete. People confuse these a lot. Both of them are infinite. I can have an infinite number of discrete numbers. I can have an infinite number of continuous numbers. It's not about how long you can keep it going as far as being continuous. So like one of the questions is the number of children a woman can have. That is a discrete number because you can't give birth to 1.5 kids. Now, I guess you can continuously have children, like for the rest of your life, that's true, but that doesn't mean the number of kids that you have is a continuous number, right? So there's infinite and there's continuous. They're not the same in math. So there's my discrete number of eggs. Continuous is a fraction. So when you're always like, I don't know if this is discrete or continuous, can you say, can I have 1.5 of these things? If your answer is yes, it's continuous. If it's a no, it's discrete. Then there's qualitatives, which is a quality. So you got labels, names, some genders, yes or no. Shirt numbers on a uniform because that's not their name. That's not their number. Like it's not like they're the 13th person on the team if they got a 13 on the back of their shirt. It's like they are number 13. Other ways to classify data are nominal, ordinal, interval, and ratio. This is on the bottom of page 15 in your textbook. And nominal means that there is no order, so NO. It's just yeses and nos, male and female. I must be on an ice cream kick because I keep talking about ice cream like chocolate, vanilla, strawberry. I guess I'm hungry. That's all every time I think of a category, I'm thinking of ice cream. Ordinal, there is an order, but you don't know a whole lot about that order. And a great example is course grades. You know A is better than a B and B is better than a C. But if I say, hey, you got an A in stats, you don't know if you got a 91 or a 98. You don't know if you got a B, if you got an 83 or an 87. So you know there's a difference between the two of them. But you don't really know how much better your A is than your B. Is your B an 89 and your A is a 91? Or was your B an 81 and your A was a 97? So you know there's a difference, but it's not a measurable, concrete difference that you can say, I did 10 points better or I did 8 points better or something like that. So that's a great example of an ordinal level. Intervals are like ordinal, that they can be put in an order and there's a meaning. We might even know what those exact differences are, but there's no starting point. There's no natural zero. So they have years. The example in the textbook says a temperature, right? There's no zero. I mean, there's a zero temperature, but that doesn't mean it's a starting point. A starting point is different than having a zero. So you can have $0, and that is a zero starting point. But a zero temperature doesn't mean that you can't have less than that, right? We've all seen wind chill factors where it's like -13. So zero is not the starting point for that. Same thing with years, right? We talk about BC and AD. Lastly, there's ratio. A lot of times we'll think about this also as a proportional growth. There is a zero that is a hard starting point. There is a clear difference in the rankings, and you know what they are. So if you buy no books, you spend no money. But $100 book costs twice as much as a $50 book. So if I buy one book, it's 50, two books, it's 100, something like that. So you got categories with some kind of order, an order with differences that I can calculate, but there's no starting point. And then I get differences and a starting point. And that's kind of the level that we'll talk about. After chapter 1, honestly, we don't talk a whole lot about what kind of measurement I have, but just what are my measurements. So what do you do with stats besides lie? Well, apparently if you look at stats books, you think that's all that we do. How to Tell a Lie from the Statisticians is a book I actually own. I also have How to Lie with Stats. There's a new one out called Naked Stats. There's lots of things that you can do with statistics, and lots of things go wrong. Sometimes people mean to do it because they're just bad. And then sometimes things happen and they didn't realize that they were making a mistake. Graphs are the biggest issue. On a graph, you should always have a zero. The tick marks, these intervals should be the same from one to the other. So 10,000, 20,000, 30,000. And the actual physical distance between the two should be the same. So like it shouldn't go 10, then 20, and then like 30 right here underneath it. That spacing between the line spacing should stay the same. Without the zeros, you look at a very different graph. So here, California and Nevada, the per capita, which is already a whole nother story that is baloney, but that's a different video. They're pretty much the same on this graph. Take out the natural zero, raise the intervals or lessen the jumps between the intervals, but keep the font the same. You see how 30 to 31 is the same from 0 to 10,000? It looks like California's doing way better than Nevada, which I suspect maybe actually be the truth. Nevada's been hit pretty hard. But when you change the axes and you take out that 0, it makes a very big difference. Another bad one is pictographs. People love pictographs. You see them a lot in political cartoons because they really drive home the point, but they're always skewed. So Japan uses 5.4 million barrels of oil. United States uses 20. So we use roughly 4 times more, right? Like 3.5 times more. In a pictograph, if I make the length here 5 or 3.5 times longer than this one, but then I also have to do that to the height. I also have to do that to the width. And so when you bump things out in a 3-dimension, something that was one not dimensional, right? This was just simply like 3.5 times this. When I go 3.5 up, 3.5 out, and 3.5 back, I've now made it 3.5 times 3.5 times 3.5. 3.5 of these little barrels will not fit in here. More like almost 64 of these guys will fit in here. So you don't just double one way. When you double multiple directions, that is going to have an exponential effect. So political cartoonists like them because it really drives home the point of how much more that we use. However, it's always skewed to make it look way worse than it actually is. We've talked about the voluntary response. Another thing that's a little shady that people like to manipulate is correlation and causality. We'll talk much more about correlation later on. Correlation, if there's a high correlation between two things, it does not mean one causes the other. And the smoking company, the cigarette companies love to talk about correlation. Smoking rate and pulse rate. There seems to be a correlation between smoking and a higher pulse rate, as well as smoking and in cancer. But just because there's a correlation, you cannot say smoking causes the pulse rate or smoking causes cancer. There are people with high pulse rates that don't smoke. There are people who get cancer that have never smoked. So because there's a correlation doesn't mean that it causes it. One of my favorites from that book that we just saw, How to Tell the Liars from the Statisticians, was about an increase in teacher salaries and liquor sales. They did a study, someplace. They saw that they paid their teachers more than they did in another district, and in the district where the teachers got paid more, liquor sales were higher. Now, if you go pay all of your teachers more money, they're not all going to stop at the ABC store on the way home. Paying your teachers more does not cause people to become alcoholics. Like that, that you cannot make that statement. But there was a correlation, probably because when you have more expendable income, you buy things you don't need, like say vodka and gin. So it was lots of things probably went up, and not just the ABC sales receipts. Small samples are bad because you will not get a good picture of your entire population. If I want to talk about people at Mitchell Community College and I talk to 3 students, I'm not going to be really getting an accurate picture of what's going on at our college. Percentages, always be wary of. If you've improved 100%, that does not mean that you are now perfect, and you cannot give 110% of anything, as you can only give all that you have, which is 100%. Percentages are great ways to manipulate data. So always kind of slow down and think about what that percent means when you see it. Loaded questions, which we see all the time, and I love to watch different news channels to see how they load the questions differently. If I say, do you think too little money is being spent on welfare, which is just a dirty word and nobody says welfare anymore, versus too little being spent on assistance to the poor? Well, if I say welfare, 19% say no. Where if I say, do you think we should spend more money on assistance to the poor, or which we usually say is public assistance, 63% yes. When you use words with negative connotations, people will shy away from that. The order that you ask questions matter. If I say, do you think traffic contributes more or less to air pollution than industry, they'll say traffic contributes more, and industry only 27% said industry. When I reversed it and said, do you think industry contributes more than traffic, they went with industry. So they just picked, most people just picked the first one they heard. It's busy lives, and it's a voluntary sample. People kind of, that's what goes in first, and that's what they remember, and that's what comes back out. People are not random. We are quite predictable, which makes us easy to manipulate. Even people who think they are very much aware fall into those traps. Non-responses. People who refuse to talk to pollsters have a very different opinion of the world around them than people who will take the time. The person who lets somebody into their house for 10 minutes to take a poll is very different than the person who refuses to open the door for many aspects. Why? It could be anything. Like, let's say you're at home and you have a couple of little kids. I'm not going to let some stranger in the house. Now, it could be that you have kids and you're worried, or maybe you're a little paranoid. I get 2 crazy beagles. They're going to bark the whole time. I don't want anybody in my house because the beagles are going to go crazy. So it's not that I just don't want people in my house. I just don't want to listen to Holly and Abby bark nonstop. So non-response people have different views of the world, and will then in fact give a very different opinion than those who will stop and take the time to let people in. Sometimes data is missing. Sometimes people drop out of the study and you can't force them to stay. Sometimes people kind of lie. They said people with low incomes are less likely to report their incomes. I imagine both extremes fail to report their incomes accurately. And the U.S. Census, well, you can't mail a census to somebody that has no home. So there's all types of data that could be missing for a variety of different reasons. When you get a bad sample, there is nothing that you can do to save those numbers. The numbers are bad no matter what. You can't take the numbers and then make your sample good. So how do you get a good sample? You have a couple of different methods. You have random, systematic, convenience, stratified, and clustered. We'll talk about multi-stage at the end. A random sample is kind of like the lotto, like Powerball. All the balls are in there. One comes up, you take it, you're done. Everybody has the same probability of being selected. A simple random sample takes those subjects and puts them into groups where everybody is the same size. So being grouped doesn't change your individual probability of being selected. It just means that instead of having to pick 1,000 out of 1,000,000 people, I just have to pick one group of 1,000. The big trick is that the groups must be the same size, or else it's going to skew the individual probabilities. We like random samples and simple random samples the best, and that's what we will normally use. Systematic kind of does that random, but takes every kth element, or sometimes we say every nth person. So I go to the computer that I have for the random number generator right here, and I take every 10th number. So it's random, but I'm specifically looking for certain numbers within this random population. And this one, I talk to every third person. Convenience is what people tend to think about as being random. But it's not random for the person who's walking the dog. The person walking the dog had every intention of being there. Just because this crazy lady hanging out the window didn't know who was going to walk by doesn't mean that this person walking just happened to randomly be there. He meant to walk there. Convenience is about the person asking the question, not the person who showed up. Convenience sampling is normally not very good because you're only in one spot dealing with one subset of people that happen to be available that time of day and all live in the same spot. So convenience samples are not very good, but they're very easy to get. Stratified is kind of like a two-step where we break them into groups, and then within the group, I have a selection process. So a big one is men and women, because it's very easy to separate just by asking, or in a survey or looking at them. And then so I break this into men and women, and then it looks like I asked everybody without a hat. If you had a hat, I didn't ask you. Or maybe I just didn't ask every second person. I skipped the second person. So it's kind of like a two-step process to get data. Cluster sampling is what you've been subjected to if you've done any course evaluations. You break everything up into groups. The groups do not necessarily need to be the same amount of people in each group, and then I just ask everybody in that group. So like, for example, when you did evaluation for one of your instructors, they didn't go to every single class that instructor taught. They just picked one of them, and then you got it. So like, I teach 4 or 5 classes, they're only going to come to one class. Maybe this is different police precincts, and they're polling all the cops at precinct 5, 28, and 16. Oh, this is voters in a precinct. And then they'll look at those and make a general statement about the whole area. Multi-stage is just doing 2 or more. So maybe it's a random sample, and then you break it up into 2 groups from there. Multi-stage is kind of like a stratified, where you're doing more than one thing. So those are your different samples that you need, and those are most of the time we'll talk about random. There are also studies and experiments. A study, you don't do anything to manipulate. You're simply there watching, or you ask a question and you write down the answer. You don't modify what's going on. So like the lady with the chimps, she's out there watching the chimps for like God knows how long now. That's a study. When we follow different cohorts through, like if you do testing in high school and stuff, that's an observational study. Cross-sectional means I take data at one point in time and I measure it, I collect it, I observe it. Retrospective means I start somewhere and I create a baseline, and then I come back some point and I pick up more data. So I go through old records, old interviews, and then I go back and I see what's going on now. A cohort or prospective is we're collecting data in future groups that share common factors. It's very popular in education, where you kind of start one spot and then you do something in the future to get, and then you take the data from the future and compare it backwards. An experiment, if you've taken any science classes, it's not any different. You're going to be manipulating something in an experiment. You want to make sure that the subjects are random, so that way you don't skew your data. You want to make sure that somebody else can repeat it to verify that data. And they've got to be able to repeat it the exact same way that you did it to ensure that your data is accurate. Blinding means that when I give the either the medicine or I administer the experiment, that the person taking the pill, or certainly the plant, wouldn't know what it is that they're getting. Are they getting the medicine? Are they getting the treatment? Or are they getting a placebo? And that will allow you to take care of some of the placebo effect that takes place. Um, so like I never forget my like 8th grade science experiment was I did one plant without Miracle Grow and one plant with Miracle Grow. Of course the plants don't know what they're getting. I knew. But it was like a blinding experiment so I can see if Miracle Grow actually worked. Double blind means that not only does the subject not know what they're getting, the person administering the experiment doesn't know. So I'm a doctor, I'm checking out different like maybe weight loss pills. I give everybody a little cup with some pills in it. Some people get cups with Tic Tacs. Some people get whatever the hot new drug for weight loss is. They don't know what they're giving, but I also don't know what I'm handing out. Now somebody somewhere knows so they can track the data. But me not knowing on the double blind doesn't mean that I subconsciously give them clues about whether or not they're getting the Tic Tac or the real weight loss drug. Confounding means that you don't leave out people. So a treatment group was all women and the placebo group was all men. Well, I can't make a statement because men and women genetically are different. It could be for any kind of ethnic groups. Age is a big thing. You can't have everybody in one group be over 25 and the placebo group all be under 25. Your bodies are different at different times in your life. So you have to make sure that the sample is good throughout all the different blinding sections. So make sure it's random, make sure it's blocked, make sure that you control that design experiment and that you have pairs, that there's somebody in the blinded or the placebo group matches up with somebody that's in the non-placebo group. Sometimes things still go wrong. That's okay. Sometimes it's a sampling error. Sometimes it's a bad instrument or something like that. And that is all of your information for chapter 1.